Hello, in this lecture we will find the diameter of the semicircle. In the drawing we have a semicircle. AB is the diameter of this semicircle. Chord AD equals to 7 units, and also we know that chord DC equals to 15 units in its size, and chord CB equals to 15 units in its size, and we want to find out the diameter of this semicircle. We know that the diameter is AB, but we want to find out the size of AB. Okay, so first of all, we will make a construction. We will connect together points B and D by a straight line. Okay, we connected together points B and D by a straight line, and actually angle ADB is a right angle. It equals to 90 degrees in its size, and it is 90 degrees because of rule number 1. Rule number 1 states that a peripheral angle resting on the diameter of the circle is equal to 90 degrees. Okay, so I will read rule number 1 again. Rule number 1 states that a peripheral angle resting on the diameter of the circle is equal to 90 degrees. Okay, so actually angle ADB is a peripheral angle, and angle ADB rests on AB, that is defined as the diameter of this semicircle. Therefore, according to rule number 1, it equals to 90 degrees. Okay, so the peripheral angle ADB equals to 90 degrees in its size because of the fact that it rests on AB, that is the diameter of this semicircle. Okay, so this is a right angle. In the next step, we will define the center of this semicircle as point O. Again, this point O, is the center of this semicircle, and then we join together by a straight line points O and C. And we will also join together by a straight line points O and D, these 2 points. Actually, chord OC, this chord is the radius of this semicircle because of the fact that it starts from the center of this semicircle, that is to say from point O, and ends at point C, that is a point on the semicircle itself. Therefore, OC is the radius of this semicircle, and OD is the radius of this semicircle for the same reason, because it starts from the center of the semicircle and ends at point D, that is a point on the semicircle itself. Therefore, it is the radius. So we will define the radius of this semicircle as R. So OD equals to R, and OC also equals to R, and also OB is also the radius of this semicircle, because of the reason that it starts from point O, that is the center of the semicircle, and ends at point B, that is a point on the semicircle itself. Therefore, OB is the radius of this semicircle. Okay. In the next step, we will focus on triangles OCD. The green triangle OCD, and we will also focus on triangle OBC, that is the orange triangle. So we focus on the orange triangle and on the green triangle. Actually, side DC of the green triangle equals to side CB of the orange triangle. Both those sides are equal to 15 units in their size. So ODC equals to CB equals to 15 units in their sizes, and also OD equals to OB. Both of those chords are the radiuses of this semicircle. So OD equals, so OD the side of the green triangle is equal to OB, the side that is the side of the orange triangle. Both those sides are equal to R, that is the radius of this semicircle. So we found that DC equals to CB equals to 15 units, OD equals to OB equals to the radius of this semicircle, and OC is a common side. It belongs both to the green triangle, and also OC belongs to the orange triangle. So OC equals to OC, it is a common side. OC equals to OC, okay, OC equals to OC. This is a common side. So we found that three sides of the green triangle are equal to three sides of the orange triangle. Therefore, the green triangle is congruent to the orange triangle. So, triangle ODC, that is the green triangle, is congruent to the orange triangle, triangle OCB. Okay, triangle OCD is congruent to triangle OCB according to side rule. According to side rule. Actually, side rule states that if you prove that all the sides of one triangle are equal to all the sides of the other triangle, then you actually proved that those two triangles can go into each other. Okay? Therefore, from the fact that those two triangles can go into each other, we can deduce that angle OCD, this angle, is equal to angle OCB, to this angle. Again, angle DCO, this angle, is equal to angle OCD, to this angle. Angle DCO in the green triangle is equal to angle OCB in the orange triangle, and if we define angle OCD as alpha, then angle OCB will be also equal to alpha, because those two angles are equal to each other. Okay, so angle DCO equals to angle OCB equals to alpha. Actually, the reason that angle DCO equals to angle OCB is according to the rule that corresponding angles in congruent triangles are equal to each other. We know that the green triangle is congruent to the orange triangle, therefore the corresponding angles, angle OCD and angle OCB, are equal to each other. Okay, so in the next step we will focus on triangle DCB, this triangle. So in triangle DCB, side DC equals to side CB. Both of those two sides are equal to 15 units in their sizes. Okay, side DC is in triangle DCB is equal to side CB. Both of those two sides are equal to 15 units. And we have a rule number 2. Rule number 2 states that in front of equal sides in the triangle, in front of equal sides in the triangle, there are equal angles. So I will read rule number 2 again. Rule number 2 states that in front of equal sides in the triangle there are equal angles. So according to rule number 2, we have in triangle DCB we have two sides that are equal to each other. DC equals to CB. So in front of CB we have this angle, and in front of DC we have this angle. So according to rule number 2, those two angles that are located in front of equal sides in triangle DCB are also equal between them. That is to say, angle CDB equals to angle CDB is equals to angle CBD. Okay, so angle CDB, this angle, is equal to angle CBD. This angle according to rule number 2. according to rule number 2. Again, angle CBD is equal, angle CDB is equal to angle CBD. According to rule number 2, those two angles are equal to each other. According to rule number 2, and if we name this angle, angle CBD, as theta, then angle CBD will be also equal to theta because of the fact that those two angles are equal to each other. Okay, so angle CBD equals to angle CDB is equal to angle CBD. Both of those two angles are equal to theta. Okay. In the next step, we will define this point as point E. This point is defined as point E. Then we will focus on triangle CDE and triangle CEB, this triangle. So actually, in those two triangles, the green triangle and the orange triangle, we know that DC, the side of the orange triangle, is equal to CB, the side of the orange triangle. Again, CD of the green triangle is equal to CB, the side of the orange triangle. Both those two sides are equal to 15 units in their sizes. Okay, so actually DC equals to CB equals to 15 units in their sizes, and angle ECD, this angle is equals to alpha in the green triangle. Angle ECD of the green triangle that equals to alpha is equal to angle ECB of the orange triangle that also equals to alpha. Again, angle ECD of the green triangle is equal to angle ECB of the orange triangle. Both those two angles are equal to alpha. And also, side EC is a common side. It belongs both to the green triangle, and side EC also belongs to the orange triangle. So EC equals to EC. EC equals to EC. It is a common side. So we actually proved that two sides and the angle included of the green triangle are equal to two sides and the angle included of the orange triangle. Okay, two sides and the angle included of the green triangle are equal to two sides and the angle included of the orange triangle. Therefore, the green triangle, triangle DEC, is congruent to the orange triangle. That is triangle ECB. Okay, the green triangle, triangle DEC, is congruent to the orange triangle, triangle ECB, according to side angle side rule. According to side angle side rule. Okay, according to side angle side rule. Actually, side angle side rule states that if you prove that two sides and the angle included of one triangle are equal to two sides and the angle included of the other triangle, then those two triangles can go into each other according to side angle side rule. Okay, so from the fact that those two triangles can go into each other, we can deduce that angle CED of the green triangle this angle of the green triangle is congruent to angle CEB of the orange triangle is congruent to this angle. Okay, so angle CED of the green triangle is equal to angle CEB of the orange triangle again angle CED of the green triangle equal to angle CEB of the orange triangle according to the rule that corresponding angles in congruent triangles are equal to each other. The green triangle, triangle CEB, is congruent to the orange triangle, triangle CEB. Therefore, the corresponding angles are also equal to each other. Therefore, those two angles are equal to each other because they are the corresponding angles in congruent triangles. So, if we define angle CED as x, then angle CEB will be also equal to x because they are actually equal to each other. So those two angles are defined as x. Okay, so angle CED is equal to angle CEB, it equals to x. Both those two angles are equal to x. And actually, in the beginning of the lecture, we made the construction. We joined together points P and D by a straight line. Therefore, DB, chord DB, is a straight line because we constructed it like this, that it will be a straight line. So chord DB is a straight line. Okay, chord DB is a straight line because we constructed it like this, that it will be a straight line because we connected together points D and B by a straight line. So actually, and because of the fact that DB is a straight line, if we focus at point E and the upper side of this straight line DB and at point E, then this angle is equal to 180 degrees. Again, if we focus on the upper side of the straight line DB and at point E, this angle equals to 180 degrees because of the fact that along a straight line at one side, in this case at the upper side, and at a specific point, the sum of the angles are equal to 180 degrees. Therefore, we can say that angle DEB equals to 180 degrees in its size. So angle DEB equals to 180 degrees in its size, again according to the rule that along a straight line, if we focus at one side, only on the upper side of that straight line, and at a certain point, that is to say point E, the sum of the angles are equal to 180 degrees. That is from one side. From one side, the size of angle DEB equals to 180 degrees. But from the other side, what is the size of angle DEB? The size of angle DEB is x degrees plus x degrees. Again, the size of angle DEB is exactly x degrees plus x degrees. That is to say, the size of angle DEB equals to 2x. Okay, so we actually arrived to this equality that 2x equals to angle DEB equals to 180 degrees. From this equality, we can deduce that 2x equals to 180 degrees. Okay, 2x equals to 180 degrees. And if we divide this equality by 2, we will get that x equals to 180 degrees over 2 is 90 degrees. X equals to 90 degrees in its size. So x is a right angle. So here actually we can substitute x by 90 degrees. We have two angles that are equal to x. So actually we have here two right angles. So we can write down that x equals to 90 degrees. Okay, so actually this is a right angle, and this angle is also a right angle. Okay, so we have here two right angles. Those two angles are right angles. And in the next step, we will focus on chord OC. Actually, chord OC, this chord OC is the radius of this semicircle. So is equal to R. It is the radius of this semicircle because of the fact that it starts from the center of the semicircle, that is to say from point O, and ends at point C, that is a point on the semicircle itself. Therefore, OC is the radius of this semicircle. OC is the radius of this semicircle. Okay. Chord OC is equal to R. And so OC is the radius of this semicircle, must be a straight line. So OC is a straight line. Again, OC is a straight line because it is the radius of this semicircle. Again, OC is a straight line. And again, we have the same rule. If we look only at one side of the straight line, if we look only of one side of the straight line, only on this side, the sum of the angles, if we focus at point E and only at this side, then the sum of the angles along the straight line OC must be equal to 180 degrees. Okay, so this angle with the arrow is equal to 180 degrees in its size, because of the fact that the sum of the angles along a straight line at one side at a certain point is equals to 180 degrees. So this angle is a right angle. This angle equals to 180 degrees in its size. So what this angle constitutes? A right angle that is 90 degrees. And it also constitutes angle OEB. So 90 degrees plus the size of angle OEB must be equal to 180 degrees, because of the fact that the sum of the angles along a straight line at one side and at a certain point is equal to 180 degrees. Okay, so actually we got this equality that states that 90 degrees plus the size of angle OEB equals to 180 degrees. So from this equality we can subtract 90 degrees, and we will get that the size of angle OEB, angle OEB equals to 180 degrees minus 90 degrees is 90 degrees. Okay, we arrive to the conclusion that angle OEB, this angle is a right angle. Okay, angle OEB, this is a right angle. Okay, so around point E we have three right angles, 1, 2 and 3, that the total sum of those three right angles are 90 degrees times 3 is 270 degrees. We will define the fourth angle, this angle, angle OED, the missing angle is Y. Okay, we'll define the missing angle as angle Y, and we have a rule number 3 that states that the sum of the angles around a point is equal to 360 degrees. So I will read rule number 3 again. Rule number 3 states that the sum of the angles around a point is equal to 360 degrees. So actually, according to rule number 3, the sum of the angles around point E equals to 360 degrees. That is to say, the sum of the three right angles that are actually 90 times 3 is 270 degrees, plus the size of the fourth angle that is Y, in total must be equal to 360 degrees according to rule number 3. So we got this equality that states that 270 degrees plus the size of angle Y equals in total to 360 degrees according to rule number 3. So from this equality we can subtract 270 degrees and we will get that the size of angle Y is actually 360 degrees minus 270 degrees is 90 degrees. So Y equals to 90 degrees in its size. So here we can substitute Y by 90 degrees. So we actually found out that all the four angles around point E are right angles. They are equal to 90 degrees in their sizes, and 4 times 90 is 360 degrees according to, so uh, the sum of the angles around point E is indeed 360 degrees according, it obeys to rule number 3. Okay, in the next step we will draw again triangles ADB and triangle OEB. We will focus on triangle ADB and triangle OEB. So I will draw them again. Angle ADB is a right angle, it equals to 90 degrees. We also know that angle OEB is also a right angle. It equals to 90 degrees. So I drew triangles ADB and triangle EOB again. We know that angle ADB equals to angle OEB. Both those two angles are right angles. So we can write that angle ADB in the big triangle is equal to angle OEB in the small triangle. Both those two angles are equal to 90 degrees in their sizes. Okay, we have this, and we also know that this angle, angle B, is a common angle. It belongs both to the small triangle, triangle OEB, and angle B belongs also to the big triangle, triangle ADB. So we can write down that angle B equals to angle B. It is a common angle. And the third angle, angle DAB in the big triangle, and angle EOB in the small triangle are also equal. Those two angles are also equal to each other. So angle DAB is equal to angle EOB. According to third angle theorem or third angle rule. Okay, according to third angle theorem, actually, third angle theorem states that if you have two triangles that has two angles that are equal between them, then the third pair of angles must be also equal in those two triangles according to the third angle theorem, because the third pair of angles is complementary to 180 degrees. So we found the two angles of the big triangle are equal to two angles of the small triangle. Therefore, the fourth angle that completes the sum of the angles in the triangles to 180 degrees must be also equal in both triangles. That is the third angle theorem. Okay, so we actually proved that all the angles in that big triangle, triangle ADB, are equal to all the angles in the small triangle, triangle EOB. Therefore, we actually proved that those two triangles are similar to each other according to angle similarity. So we can write down that the triangle ADB, the big triangle, is similar to the small triangle, triangle EOB, this triangle, according to angle similarity. So I read again the things that I wrote. So the big triangle, triangle ADB, is similar to the small triangle, triangle EOB, according to angle similarity. Angle similarity states that whenever you prove that all the angles in one triangle are equal to all the angles in the other triangle, then those two triangles are similar to each other according to angle similarity. So actually, from the fact that those two triangles, triangle ADB and triangle EOB, are similar to each other, the following relationship exists between the sides of those two similar triangles. The relationship is that OB, the side of the small triangle, over AB, the side of the big triangle, is equal to OE, that is the side of the small triangle, over AD, the side of the big triangle. Okay, again, the following relationship exists between the sides of those two similar triangles, that OB over AB equals to OE over AD. But what is the size of OB? OB is the radius of the circle. And also we know that OA is also the radius of the circle because of the fact that it starts from the center of the circle and ends at point A, that is a point on the circle itself. Therefore, OA is the radius of this semicircle. So what is the value of AB? AB equals to R plus R. Okay, AB is equals to 2R. AB is defined as the diameter of this semicircle, so we can know that AB equals to 2R even without looking at the drawing itself. Okay, so AB equals to 2R, and then we have OE over AD. What is the value of AD? AD equals to 7 units. It is given us in the question. So in total we got that R over 2R equals to OE over 7. R over 2R is 1, so R is cancelled. So in total we will get that 1 over 2 equals to OE over 7. Okay, so here we can multiply this equality by 7 in order to get the value of OE. So we will get that OE equals to 7 over 2 units. Okay, OE equals to 7 over 2 units. Again, OE equals to 7 over 2 units. So we can write here that OE equals to 7 over 2 units. OE equals to 7 over 2 units. And what is the value of the size of EC? EC, from the drawing we can see that EC equals to OC minus OE. Again, EC equals to OC minus OE. OC minus OE. Again, EC equals to OC minus OE. But what is the value of OC? I've already showed you that OC is the radius of this semicircle because it starts from the center of the semicircle and ends at point C, that is a point on the semicircle itself. So OC is the radius of this semicircle, so it equals to R minus OE. What is the value of OE? OE equals to 7 over 2 units. So in total we found out that EC equals to R minus 7 over 2 units. So we can write here that EC equals to R minus 7 over 2 units. Okay, again, EC equals to R minus 7 over 2 units. So in the next step we will focus on the two right triangles. In the orange color we have triangle CEB, that is a right triangle because of the fact that angle CEB is a right angle, and we also have triangle OEB that is also a right triangle because of the fact that angle OEB, this angle is a right angle. So we focus on those two right triangles. The right triangle CEB and triangle OEB. Okay, as you can see from the drawing, side EB is actually a common side. It belongs to both those two right triangles. Side EB belongs to the right triangle, triangle CEB, and side EB also belongs to the right triangle, triangle OEB. Okay, so we can implement the Pythagorean theorem in those two right triangles. So we'll make the equality that states that EB squared equals to EB squared. Okay, EB squared equals to EB squared. So we will relate to this triangle, the right triangle OEB for the first EB square, and then we will relate to this right triangle for the second EB square. Okay, so we will get that if we relate to this right triangle, EB square will be equal to OB square minus OE square. OB square minus OE square. And the second time we relate to this right triangle, so here EB square will be equal to CB square minus EC square. Okay, so in total we got that EB square equals to OB square minus OE square, that equals to CB square minus EC square. But what is the value of OB? OB equals to R. So OB square is R square minus OE. OE equals to 7 over 2 units. So OE square will be equal to 49 over 4. Equals to CB square. CB equals to 15, so CB square is 15 square, so 15 square is 225. Minus EC square. We've already found out that EC equals to R minus 7 over 2, so EC square will be equal to R minus 7 over 2 square. So in total, we add to this equality that states that R square minus 49 over 4 equals to 225 minus R minus 7 over 2 square. Okay, so R square minus 49 over 4 equals to 225 minus, so r minus 7 over 2 squared is actually r squared plus 7 over 2 squared is 49 over 4 minus 2 times r times 7 over 2. So in total we got this equality. So here we will open the brackets on this side of the equation, equality, and we will get that r squared minus 49 over 4 equals to 225 minus r squared minus 49 over 4 plus, here we have 2 in the numerator and 2 in the denominator, so 2 over 2 is 1, so 2 is cancelled, and we left only with 7r, so minus 7r is plus 7r. So here we have minus 49 over 4 in this side of the equality, and we have minus 49 over 4 on the other side of the equality, so we can cancel minus 49 over 4. So what is left? So first of all we will add r squared to this equality, and we will get that r squared plus r squared is 2r squared equals to 7r plus 225. So in total we got that 2r squared equals to 2r squared equals to 7r plus 225. So here we will subtract 7r and 225 from this equality, and we will arrive to a quadratic equation that 2r squared minus 7r minus 225 equals to 0. So we got to a quadratic equation, and the coefficients of this quadratic equation is a equals to 2, b equals to minus 7, and c equals to minus 225, and the variable of this quadratic equation is r, so x equals to r. In general, we have the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. So that is the general formula for a quadratic equation, when a, b, and c are the coefficients of this quadratic equation, and x is the variable that we want to find out, and we will find the value of x according to a special formula that states that x equals to minus b plus minus root of b squared minus 4 times a times c over 2a. Okay, we will find out the value of a according to this special formula. Okay, but we have already found out that x is the variable of this quadratic equation. X equals to r. Actually, minus b so my b equals to minus 7, so minus b will be equal to minus 7, that is 7 plus 7 plus minus root of b square is 7 square is 49 minus 4 times a. 4 times a is 2, so 4 times a is 8, times c is minus 225 over 2a. A is 2, so 2 times 2 is 4. So in total we got to this equality that r equals to the root of 49 times minus 8 times minus 225 over 4. Minus 8 times 224 is 1800, so I write it down that r equals to 7 plus minus, so it is the root of 49 plus 8 times 225 is 1800 over 4. Okay, so here r equals to 7 plus minus root of 1800 plus 49 is 1849 over 4. So in total we got that r equals to the 7 plus minus root of 1849 over 4. The root of 1849 is 43, so I write it down. R equals to 7 plus minus the root of 1849 is 43 over 4. Okay, so we got that r equals to 7 plus minus 44 over 4. So we have here two solutions to this quadratic equation. The first solution is R equals to 7 plus 43 over 4. 7 plus 44, 7 plus 43 is 50. 50 over 4 is 12.5. So the radius of the semicircle equals to 12.5 units. And we have also the second solution, that R equals to 7 minus 43 over 4. 7 minus 43 is minus 36. Over 4 is minus 9. So we arrived to the solution that states that the radius of the semicircle is minus 9. But because of the fact that the radius of the semicircle must be a positive number, this solution is incorrect. We'll cancel this solution, so we left only with the solution that R equals to 12.5 units, and the diameter of the semicircle is actually AB, that is equals to 2R. So the diameter of the semicircle, D is the diameter, it equals to AB, that is also equals to 2R, 2 times the radius of the semicircle, so it equals to 2 times, R is 12.5 units, so 2 times 12.5 is 25. So the radius, the area, the diameter of the semicircle, that is AB, equals to 25 units. Okay, so actually the final answer to the question is that the diameter of this semicircle, that is to say AB, equals to 25 units. Okay, so now I'll summarize the lecture. Actually, we wanted to find out the diameter of this semicircle, and we know that AB is the diameter of this semicircle, but we want to find out the size of AB, the value of AB. We know that AD equals to 7 units, chord DC equals to 15 units, and chord CB equals to 15 units in its size. And we want to find out the diameter AB of this semicircle. Okay, so first of all, we made a construction. We connected together points D and B by a straight line, and so here angle ADB was created by the construction, and actually angle ADB is a right angle. It equals to 90 degrees according to the rule that states that a peripheral angle resting on the diameter of the circle or semicircle is equal to 90 degrees. Okay? Rule number 1 states that a peripheral angle resting on the diameter of the circle is equal to 90 degrees, and actually angle ADB, this angle rests on AB, that is the diameter of this semicircle. Therefore, according to rule number 1, this angle ADB, the peripheral angle ADB equals to 90 degrees in its size. Okay, then we defined the center of this semicircle as point O, and we connected together points O and C by a straight line, and we also connected together points O and D by a straight line. Then we focused on the green triangle and on the orange triangle. We know that side DC of the green triangle that equals to 15 units is equal to side CB of the orange triangle that also equals to 15 units. We also know that OD equals to OB. Both those two sides are the radiuses of this semicircle, therefore they are equal to each other. And OC is a common side. It belongs to both the orange triangle and it also belongs to the green triangle. So OC equals to OC as a common side. So we actually proved the three sides of the orange triangle are equal to three sides of the green triangle, or we proved that all the sides of the green triangle are equal to all the sides of the orange triangle. Therefore, we actually proved that the orange triangle is congruent to the green triangle is congruent to the orange triangle according to side rule. Okay? So those two triangles congruent to each other. Therefore, from this fact we can deduce that those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. So actually angle ODCO is equals to angle DCB, and if we define this angle as alpha, this angle also will be equal to alpha because those two angles are equal to each other. So angle DCO is equals to angle DCB equals to alpha. Then we focused on triangle DCB. This triangle, we know that side DC of triangle DCB is equal to side CB of triangle DCB. Both of those two sides are equal to 15 units in their sizes. So DC equals to CB equals to 15 units in their sizes. And we have rule number 2 that says that in front of equal sides in the triangle there are equal angles. So actually in triangle ADB we have two sides that are equal to each other, and according to rule number 2, in front of this side we have this angle and in front of this side we have this angle. So according to rule number 2, those two angles are equal to each other. Okay, again, rule number 2 states that in front of equal sides in the triangle there are equal angles. Therefore, angle CBE equals to angle CBD. Those two angles that are located in front of equal sides are also equal between them. Okay, and if we define one angle as theta, then the other angle will be also equal to theta. So actually, angle CBD equals to angle CDB equals to angle CBD. Both those two angles are equal to theta. And then we focused on the orange triangles, triangle. We defined this point as E, and we focus on the orange. We focused on the orange triangle, triangle CEB, and we also focused on the green triangle, triangle CED. So So in those two triangles, we know that CB equals to DC equals to 15 units in their size. It is given us the question that those two sides are equal to each other, and we also know that those two angles are equal to each other. They both equal to alpha, and EC is a common side. It belongs to both triangles, so EC equals to EC. So we actually proved that two sides and the angle included in the orange triangle are equal to two sides and the angle included in the green triangle. Therefore, we actually proved that those two triangles can go into each other, or the orange triangle can go into the green triangle, according to side angle side rule. Side angle side rule states that whenever you proved that two angles and the two sides and the angle included of one triangle are equal to two sides and the angle included in the other triangle, then you actually proved that those two triangles can go into each other according to side angle side rule. Okay, so those two triangles can go into each other, therefore we can derive from it that those two angles are also equal to each other. Or angle CEO, angle CEB is equal to angle CED. Okay, and we define those two angles as x. So actually, by the way, these two sides are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, therefore those two angles are equal to each other. So we defined one angle as x, so the other angle must be equal to x because those two angles are equal to each other. So angle CD is equal to angle CB equals to x. We know that chord DB is a straight line because we built it like this. We connected together points D and B by a straight line, therefore chord DB is a straight line, and as a straight line we know that along a straight line, if we focus only on one side, on the upper side and at point E, the sum of the angles along a straight line at one side and at a certain point must be equal to 180 degrees. So actually angle DEB from one side it equals to 180 degrees because the sum of the angles along a straight line at one side only and at a certain point equals to 180 degrees. So from one side we know that angle DEB equals to 180 degrees. But from the other side, what is the size of angle DEB? It equals to the size of this angle that is x plus the size of this angle that is also x. So from the other side, the size of angle DEB equals to 2x. So we have this equality. From this equality, we can derive that 2x equals to 180 degrees. And if we divide this equality by 2, we will get that x equals to 90 degrees. Okay, so we can substitute x by 90 degrees here, and we can substitute x by 90 degrees here. Okay, and then we focused on chord OC. OC is actually the radius of this semicircle because of the fact that it starts from point O and ends, that is the center of the semicircle, and ends at point C, that is a point on the semicircle itself. Therefore OC is the radius of this semicircle, and as a radius it must be a straight line. So OC is a straight line. And again, we have the rule of a straight line, that along a straight line, if we focus only on one side of the straight line, and at a certain point the sum of the angles equals to 180 degrees. That is to say, 90 degrees plus this angle must be equal to 180 degrees. Again, we focus only on the right side of the straight line OC, and at point E the sum of the angles here is 180 degrees. So this angle, that is 90 degrees, plus angle OEB must be equal to 180 degrees. Again, along the straight line OC at a certain point E, and at the right side the sum of the angles equals to 180 degrees. That is to say, 90 degrees, this is 90 degrees plus angle OEB must be equal to 180 degrees. Here we can subtract 90 degrees from this equality, and we will get that the size of angle OEB is 90 degrees. So actually this angle is a right angle. Angle OEB is a right angle. Then we defined this angle as y. That is to say, angle DOED is equals to y. And according to our definition, so then we have rule number 3 that states that the sum of the angles around a point is equal to 360 degrees. And if we focus on point E, according to rule number 3, the sum of the angles around point E is equal to 360 degrees. And what we have around point E? We have around point E 3 right angles, and the sum of them is 90 times 3 is 270 degrees, and we also have angle Y. So according to rule number 3, 270 degrees, that is the sum of the 3 angles, plus the size of the 4th angle must be equal to 360 degrees. So we can subtract 270 degrees from this equality, and we will get the value of y. We got that y equals to 90 degrees. So this angle is a right angle. Actually, we arrived to the conclusion that all the 4 angles around point E are right angles. Okay, then we focused on triangle ADB. That is actually a right triangle, because this angle is a right angle, and we also focused on the right triangle, triangle OEB. So I do them again. I do these right triangles again. This is triangle ADB, and this is triangle EOB. So in these 2 triangles we have 2 angles that are right angles. So angle ADB equals to angle OEB equals to 90 degrees. Those angles are right angles, so they are equal to each other. And we also have angle B, that is a common angle. Angle B belongs both to the small triangle, triangle EOB, and angle B also belongs to the big triangle, triangle ADB. It is a common angle, therefore we can state that angle B equals to angle B. It's a common angle. And the third angle, that is angle DAB in the big triangle and angle EOB in the small triangle, are also equal between them. Those 2 angles are also equal between them, according to the third angle theorem. The third angle theorem states that if you have 2 triangles that have 2 equal angles, then the third pair of angles must be also equal between them, according to the third angle theorem, because the third pair of angles completes the sum of the angles in the triangles to 180 degrees. Therefore, we found that we have here in those two triangles two angles that are equal to each other. Therefore, the third pair of angles, those two angles must be also equal to each other according to the third angle theorem, because the third pair of angles, those two angles, complete the sum of the angles in the triangles to 180 degrees, therefore they are equal to each other. Okay, so from the fact that all the angles in the big triangle ADB, are equal to all the angles in the small triangle OEB, we can deduce that those two triangles are similar to each other according to angle similarity. Okay? And from the similarity between those two triangles, the following relationship exists between the sides of those two triangles. OB over AB equals to OE over AD. Again, OB over AB equals to OE over AD. What is the size of OB? OB equals to R. What is the size of AB? AB equals to 2R. So OB over AB is R over 2R. That equals to OE over AD. What is the size of AD? AD equals to 7. Okay, so in total we got that R over 2R equals to OE over 7. Then we multiply this equality by 7, and we found out that the value of OE is 7 over 2 units. Then what is the value of EC? Actually, is EC equals to OC minus OE. Okay, EC equals to OC minus OE. But OC is the radius of the semicircle, and OE equals to 7 over 2 units. So in total, EC equals to R minus 7 over 2 units. Okay, EC equals to R minus 7 over 2 units. Okay, then we focused on two right triangles in the orange color. Triangle CEB is a right triangle because angle CEB is a right angle, and triangle OEB is also a right triangle because angle OEB is a right angle. So we implemented the Pythagorean theorem in those two right triangles, and we added the equality that says that EB square equals to EB square. The first EB square relates to these right triangles. Here EB square equals to OB square minus OE square. Okay, EB square equals to OB square minus OE square. And the second OB square in the equality is related to this triangle. Here OB square equals to BC square minus EC square. Okay, OB square equals to BC square or CB square minus EC square. Okay, but we know that OB equals to R, and OE equals to 7 over 2, and also CB equals to 15 units, and CE equals to R minus 7 over 2. Okay, and after we solve this simple equality, we got to the quadratic equation that 2 times R square minus 7r minus 225 equals to 0. So here the coefficients of this quadratic equation is a equals to 2, b equals to 7, and c equals to minus 200, b equals to minus 7, and c equals to minus 225. And the variable here in this quadratic equation, x equals to r, r is the variable of this quadratic equation that we want to find out. And we have the general formula for a quadratic equation, that ax squared plus bx plus c equals to 0, and x is the variable that we want to find out, and we will find out the value of x according to a special formula for x. And we know that x in our quadratic equation equals to r, b equals to minus 7, and c equals to minus 225, and a equals to 2. So we put the data inside this quadratic equation, and we found out that the radius of the semicircle equals to 12.5 units. But we have another solution for the quadratic equation, that r equals to minus 9, but the radius of the semicircle must be a positive number, so minus 9 is a negative number, therefore it is impossible, so it is incorrect answer. So we only left with the answer that the solution for r, that is actually 12.5 units. And then if the radius is 12.5 units, then the diameter is 2 times the radius. It is actually equals to AB, that is the diameter of the semicircle, and 2 times the radius is 2 times 12.5, that is equals to 25 units. So we found out that the diameter of this semicircle, that is to say AB, equals to 25 units. Okay, thank you very much.